Alright, question F. A particle moves in the xy plane, starting at the origin 0, 0. At each turn, the particle may move in one of the two ways. It may move 2 to the right and 1 up, that is translated by 2, 1, or it may move 1 right and 2 up, that is translated by 1, 2. Okay, so what is the closest particle may come to the point 25, 75? Good. Okay, so any ideas? What I would do is that, well, 25, 75, right? So actually, let's try to get there first. Because if we get there, then the answer is 0, right? Then happy days. Okay, so because the y coordinate is much bigger than x coordinate, right? So let's try to use this 1, 2 step. Okay, so I keep on doing that until I get to 25. I get 25, 50, right? Okay, so that's the point that I will get to. But then the thing is, that's not the point we want, right? Okay, but the idea is that this point has a much bigger y coordinate, so we probably want to use this step instead of the first one, right? I mean, if you use the first one, you're going more on the x than the y, which is counterintuitive, right? Because now we have a much bigger y coordinate to deal with, so we want to get there, right? Using the 1, 2 move instead of the 2, 1 move. Okay, so what points do we hit on the 1, 2 move? The points we hit are anything which is on the y equals to 2x line, right? Because the gradient is 2, right? If you think of the 1, 2 vector, it looks like this, right? This is 1, 2. So y equals 2x, right? And we are starting from the origin. So that's why y equals 2x. So let's draw a picture to visualize this. So axes, y equals 2x. All right, 25, 75. So we know that we pass through 25, 50, right? So if 25, 50 is here, then this is 25, 75. All right, yeah? So, warning, this is not the shortest distance, right? This is not the shortest distance. Where's the shortest distance? Where's the shortest distance? The shortest distance is when you're perpendicular to y equals 2x, yeah? Let me erase this blue one. So it's when you're perpendicular, which is this side, right? When you're perpendicular. Good, okay, so how do I get that? How do I get that that point there? Okay, well then you just figure out the equation of the other line, right? So the gradient will be -1/2, so y equals -1/2 x plus c. Okay, now I'm going to figure out the c, so 75 equals -25/2 plus c. So what's c? c is 175 divided by 2. Good, okay, so now I just solve simultaneous, yeah? I solve simultaneous to get that point. So simultaneous with y equals 2x, yeah? So we get the intersection point. Cool, okay, so 2x equals -1/2 x plus 175/2. Multiply whole equation by 2, 4x minus x plus 175. Okay, what did I do? 4x equals -x plus 75. Okay, so 5x equals 75. So x is 15. Good, okay. If x is 15, what happens? If x is 15, then what is my y? So y equals 2x, right? So y is 30. Cool, great. But what am I doing? What am I doing? What am I doing? I forgot a 1 here, right? 175. Okay, so 175 divided by 5. What is that? That is 35. Yes, that's much better, right? Because surely the intersection point has an x coordinate bigger than 25, right? Not less than 25. Okay, so if x is 35, then y is, what is it? When x is 35, y is 70. All right, good. So that's my point. So let's do the distance then. So it's the distance between 25, 75 and 35, 70. All right, which is 5 squared plus 5 squared square rooted, which is exactly, what is this? 5 root 2, is it? Oh, no, wait. Okay, too late in the day. 10 squared plus 5 squared. God. Okay, 10 squared plus 5 squared, which is square root of 125, which is 5 root 5. Right, 5 root 2 is not an answer to the question. Good, okay, there we are. All right, don't make silly mistakes as I did. All right, I'm not very awake, I suppose. So, option B.